Hi there once again, and welcome to another Expresso mechanic tutorial. And in this one we're going to be producing what you see before you, which is a rig to produce bubbles travelling through a fluid and of course through a pipe. In order to achieve the desired result, we're going to be using a combination of Expresso, thinking particles and volumes. That's what we're going to be about in this tutorial, so without further ado, let's see if we can make this happen. We start by bringing in an arc and we'll set it in the ZY plane, make its radius 100, and then I'll switch to my right hand view, so F3, and we can work with our start angle, which needs to be 180, and we go through to 90, and that's what we want to do. We'll move this. In fact, what I'll do first is bring in snapping, so we'll enable snapping. Grid work plane we want, but we don't want grid line. That's fine. And then we can move the arc into place somewhere here. We could go one step higher, actually. I think we'll go there. So we can now think in terms of making the arc editable. So we'll hit C, go into points mode, and with the spline pen tool, we can just create our pipe. So we can just put a point there, escape, click on here, and our endpoint wants to be over here. So we've got that set up and it's ready to go. Moving on from here, let's think in terms of making this into a pipe. We'll bring in a circle, we'll leave it in the XY plane, its radius will be 50, and we want it to be a ring. Its inner radius will make 45, and that's perfect for what we need. Okay, fantastic. Another thing I'll also do with this arc, I'll just select it, just check what I've got here. I want my intermediate points to be uniform, and it is a Bezier, so that's fine, that's set up okay. The important thing here is to make sure that the intermediate points are uniform, because if they're set to adaptive, that won't work out, so I don't want that to be the case. Moving on from here, we can select both of these, hold down Command and Option and drop them into a sweep. And that gives us a pipe. Let's see what we've got here. And we can see that we've got caps on the end. That's absolutely fine. Now, up to you whether you put rounding on it. You can do that if you wish. I don't think there's any real reason to do so because they're not, the ends of it are not really going to be seen. So I'm not going to bother doing that. Okay, fantastic. So we've got our pipe. Moving on from here, we need to duplicate our arc. So we'll duplicate that. And we need to create an inner piece and also some water. So with the water, we might as well do that first. We'll bring in another circle. Just drop this beneath the arc. And this time, we don't want it to be a ring, but we do want this to be 47 in radius. We'll select both of these, Command Option, and drop them once again into a sweep. And they're the wrong way around, so we need to do that. And that's fine. We've now got our water, which is great. What we will do, just to make this distinguishable, and it's going to be made invisible for our tutorial, although you would put a texture on it, of course, if you wanted to render it and make it look like water. We'll just say automatic, and we'll just make this a blue so that we can see where it is, and we can see that it's touching the sides of our pipe, and that's working as we need it to. So we'll call this water, this one pipe. We just need the inner now. So let's work on that. We'll make the water disappear. Just make that invisible for now so that we can see what we're going to do with the inner. And once again, we can copy this arc. And the inner, we need again another circle. Drop this just above the arc. And this circle needs a radius of 40. Select both once again, Command Option, drop them into a sweep. And we've got our inner. And we can see that it's just inside the inner wall of the pipe, and that's going to be important. So we'll call this inner. And then the next step is to hit C to make it editable. We can just lose all of these. We don't need to worry about those. Because this object does need to be a geometric object as opposed to a parametric object if it's going to work with our thinking particles, because they're actually going to be colliding with this and moving around the pipe. Okay, fantastic. So we've got our 3 objects completely made, and they're all going to work out for us. Now the only thing we could do with the inner, in fact I'll take it back a couple of steps. What I should do is remove the caps. If we just say no caps, because we don't want those. And the water, we could also do the same with that if we wanted to. Although with a body of water, technically it would have caps, so we'll leave those in. But anyway, that's fine. So we've got the inner and that's ready to go. So let's just hit C and then we will remove all of these. Fantastic. And that's all working as it should. Moving on from here, we can think about bringing in some more objects to get this thing moving. And that will be our next step. What I'll do with my pipe, I will give that a render tag and it will be a display tag. We'll switch it on and we'll say we want to use isopalms and we also want to use lines. So we can see through our pipe and we can see that the uniform spline is working really nicely for that. The inner, we'll also add one to that, I think, as well. If we just drag this, command drag this onto here and leave that like that, we can now see through that, and we'll probably do the same, I think, with the water. Just put that there and then we can do this. And now we can see everything is in place and it's all as it needs to be. Okay, let's think about where we're going to emit our particles from. We'll bring in a disk for this and we'll give it a radius of 40. So it's going to emit within the inner. That's what we need it to do. Now, as with the inner, the disk needs to be made editable because otherwise it just won't work with the thinking particles. So we've got that ready. The next step will be to bring in a sphere. And this will be the geometry that we'll be using for our thinking particles. I say geometry, but we're actually going to leave it as a parametric object. We can give it a radius of 40. Or I beg your pardon, not 40, 4. That's better. Give it a radius of 4. We'll leave the segments at 32 and we'll make this an icosahedron. And we can leave everything else as it is, or leave the render perfect as it is, that's fine. So we've got our elements ready, and these are as many elements as we actually need to make this thing work. Moving on from this particular step, we can bring in a null, call it Expresso. We can give it the Expresso tag. We've got the editor open and we're ready to start working with our thinking particles and getting this thing doing what we want it to. The first node that we need to reach for will be a P matter waves. So in our thinking particles generators, P matter waves, we'll bring that in. Let's have a look at its parameters. The random seed, you can adjust this in any way you like or leave it as it is. I just made mine 1, 2, 3, 4, 7 and I found that worked okay for me. But as I say, have a play around, do whatever you like. It needs to emit from an object and we said that the object would be the disk, so we'll bring that into here. Don't really need to worry about anything else here. The birth type, now that needs to be rate, and it doesn't want to be 100, we'll make it 20. Once again though, if you want to have more bubbles, you can make it a bigger number. If you want less, make it smaller. And the birth type does need to be constant, we'll leave that as it is. The life, let's make that 500. It's a little bit irrelevant. I mean, the important thing is that they all birth here and they all travel through the length of the pipe. At the end of the pipe, we're going to do something else a little bit later, so we don't really need to worry too much, but put 500 in there as a round figure. That's not too bad. No life variation, because when bubbles are born in a fluid, they don't pop. They might be able to break up and form other bubbles, smaller bubbles, but they cannot burst completely. So we don't want any life variation. We want them all to last for 500 frames. And again, we'll leave the life type as constant. The speed, I'm going to make 200, and I will give it a variation of 40%. That way we simulate currents and eddies going on in the fluid. Again, we'll leave this speed type as constant. Our size, 10 is fine for that, but we will make a variation of 50%. And again, we'll leave the size type as constant. We don't need to worry about anything else. So that's as much as we need to do in our P matter waves. Now, we also need to think about some groups. So if we come into our simulate menu here, select thinking particles settings, at the moment we've got an all group. If I hold down my control key and click on the all, I can add a group, and I'll do that twice. So I've got group 1 and group 2. You can rename these if you want to, but I'll just leave them as they are. What I will do is select them and change their colors. So group 1, I'm going to make green, and group 2, yellow. Let's just go into here and make that yellow so that we can distinguish between them easily. Fantastic. So let's move on from here and think about what we're going to do. For a start, we can reach for a group. So in our standard menu, we want a P group. We'll get one of those in, and its group needs to be group 1. So we'll drop that in there and add this here. Just plumb that in. Now, we also need to work with our second group. What we're going to do, if we reach for our system presets over here, we can find a random node in here. So we want, let's have a look, see where we are. Calculations, no, it's not in there. Whereabouts is it? It's random integer is what I want. Let's have a look at our general presets. There we are, random integer. That's the one that I need. So I've got my random integer. Lower limit will be 0. The upper limit will be 9. Random seed, well, you can type anything in there. Again, 1, 2, 3, 4, 5, whatever you want to put in there, or just even one number, 7. It doesn't matter what it is. But we can work with this from here now. So what we're going to do is generate a random number between 0 and 9 at every frame. That's what's going to be coming out of here. So what we can do is bring in a compare node, so logic compare, and we can compare this to greater than or equal to, I'm going to say here, and I'm going to put 3. So if we're greater than or equal to 3, I want us to actually use the second group. I want what's birthed here to be placed into the second group. That being the case, we need to reach for a second P group, bring that in here. And on this occasion, we want to drag group 2 into here. We also want to add an on port. And what we'll do is command click and say ports show names so that we can see what we're doing. We can connect the particle birth output port to our particle input port on the P group. And then from here, we can simply do this. Okay, let's give this a trial run and see if we're actually getting anything. And we can see that we are. We're getting a combination of green and yellow ticks representing our particles. Now, obviously, at the moment, they're not behaving like a fluid. They're just going straight through our pipe, but we've got to deal with that a little bit later. And that's working as it should. So let's move on and think about what we need to do next. We'll just close this up for now. Let's just make this a little bigger. The first thing we need to do is bring in a p-pass node. So we'll grab a hold of one of those. So in our TP initiator menu, p-pass. We'll work with our first group. And I shouldn't have closed my thinking particles settings up so quickly. Grab group 1 and drop that into here. So we've got our group 1 in our parameters. Just leave this here. And we can think about what we're going to do with this first group. For a start, we need to give it a shape, because at the moment we've just got ticks for our particles and we want them to be spheres. So we'll bring in a P shape. So in our standard here, P shape. And we can connect the output of our p-pass to the none input there. Or it currently says none, but what we're going to do is bring in our sphere and drop it here. And then we can think about working with what we've got going on here. Now, we want our radius, our bounding radius, to be 1. That's the only thing we need to change. Render instance, we won't worry about that. But that's as much as we need to do in there. So we've got a shape for our first group. Moving on from here, let's control the size. So in our thinking particles, once again, standard menu, P size, bring one of these in. And we can connect the ports. Now in our P size, we're going to make this 5.1. You can make it a different size if you wish, again for you to play around with, but I'm going to make mine 5.1 and I want a variation of 90%, so a lot of variation here. We won't worry about overage. That controls the first two elements of what we got here. So if we just give this a run now, let's see what we get. Do we get any difference? Well, we don't, and the reason we don't is because we need to set up our TP geometry. In our thinking particles, TP geometry, let's just grab one of those in, and now we can see that we are getting spherical particles. Let's just drop this down at the bottom. Now our particle group wants to be group 1, so we'll drop that in there, and let's see what we're doing now. So we can see that we are getting different sized particles. Now at the moment they are, I think, perhaps a little bit too big. And we can easily work with this and make them smaller. So 5.1, let's make this something like 3. And let's see what we get now. Now that's more reasonable. I think that would work better. That would work better. I mean, I think that's okay. They look like bubbles. And yeah, I mean, I think that they've got a good size about them now. It's funny because I used 5.1 in my practice file and it was fine, but it doesn't always work out, so if it doesn't, just change it. That's all that needs to happen. So 5.1 will make 3 in the size, and we'll leave the variation at 90%. Now at the moment, they're still not really behaving quite like bubbles, and fortunately for us, we actually have a bubble node from within our dynamics. We've got p-bubble. So let's bring that in, and we'll connect that to our p-pass. And let's set this up. Now the amplitude, we want that to just be 20. We don't want to go too mad with the amplitude. The variation we'll make 50%. The speed we'll leave at 50%. And the speed variation 50%. And then the phase variation at the bottom here, we'll make that 20 degrees. And let's see what that's done. And we can see now that they're swaying from side to side and they are behaving more like bubbles. So that adds another dimension to it that just makes it that bit more realistic. Now at the moment they're not touching the pipe, or at least the inner object that we created within our pipe. And that's our next step. So we need a P deflector. So from our thinking particles, we can come down to our dynamics again, P deflector, and we can connect our particle group to the input. In our P deflector, we need an object, and we need that object to be the inner. And as you can see, we've got a lot of things with regard to our parameters within this particular node, and we need to set this up correctly. Again, you can play around with the seed. I just put mine as 1, 2, 3, 4, 9. The deflector type is the next thing that we need to worry about, and that needs to be object. That's set that up as it needs to be. The collision type, we can say back, because this will be actually they will be colliding with the inner faces of our inner object. So back is important there. The offset type, we can set this to user-defined travel, and the offset needs to be 20. We'll make that 20. Now let's move on from here. The variation, we don't want any really. That's no real need for that at all. In fact, our offset, I beg your pardon, it should be 10. Make it 10 and don't put any variation. The bounce, I'm going to make 110%. I found that worked better than 100%. But again, by all means, have a play around to see what you can do. We'll give it a variation of 10%. Our surface, we'll make 100%. And our energy, 20%. Everything else we can ignore. We need to worry about friction, spin, chaos. Chaos can make them travel in the opposite direction and things like that. We don't want to do that. And velocity inheritance, what that does actually is inherit the velocity of the objects that the bubbles are colliding with. Well, the object that they're colliding with is stationary, so it has no velocity. Therefore, they just inherit 0, and it could potentially bring them to a standstill. So we don't want to do that. Right, let's give this a play and see what happens. And now we can see they're starting to flow around the pipe. We'll give ourselves 1,000 frames so that we can see exactly what's going on. So yeah, that particular group is now working as it should. They're still coming out of the pipe, which we don't want. We're going to deal with that a little bit later, as I say. But before we do, we'll deal with our second group. So we're going to need to replicate all of this, but with our second group, and make some changes here and there to make them behave the way we want them to. So let's bring in another P-pass. And on this occasion, we'll pull our group 2 into there. And then we can think about what we're doing next. Well, what we might as well do, we'll just command drag to copy all of these and then set them up accordingly. Let's just connect these up. Okay, fantastic. Now the deflector, that will be exactly the same. There's no need to make any changes in there. But we will make some changes where we need to. The P shape, once again, we don't need to change the object, but we will change the bounding radius, and we'll make that 1.5 on this occasion. The P size, let's see what we've got in there. We can make this 3.5, and our variation on this occasion, I'll make 100%, just to make that a little bit different. Our bubble, I'll just increase the amplitude to 24, and the phase variation I'll make 10 degrees, and everything else I'm going to leave the same. That should work fine. And that sets up our second group. Now let's just see what's going on with this one before we take the next step. Okay, so they're all behaving as they should now. The only thing that they're not doing, of course, is showing us any geometry, because we need another TPGeometry. So let's bring it in one of those. TPGeo, and drop this down here. And this one will be group 2. And let's see what we get now. And there we go. And we have our two particle groups behaving really nicely. Fabulous. So we can move on from here and take our next step. We'll work with volumes now. So we'll bring in a volume builder, drop this down here, and our TPGeometry needs to be placed in there. And we can see that this is starting to work. If we get a hold of our builder and we make our voxel size 3, that's okay. So we've got that set the way we want it, and we also need an SDF smooth. Now the SDF smooth will make the strength 50, and that's good for us. The operator should be Gaussian. That worked, I think, best for me. You can try some of the others if you wish to, but I found the Gaussian worked really well for me, and we'll just make the iterations 2. Now, a lot of our particles have now disappeared, and the reason for that, if we go into our size here, originally I said it should be 5.1, and I then corrected it and said it was 3. That was actually wrong. I should leave it at 5.1 because that's the size that it needs to be in order for this to work. At the moment we're still not seeing them, but don't worry, we will. If we select the volume builder now and hold down our option key, we can drop this into a volume mesher, and then we can work with this. We'll change the voxel range threshold to 10%. That's where it needs to be. And we will create a curvature map, and we'll leave the curvature direction set to both. And that's as much as we need to do to set this up. Now let's just rewind to 0 and play this through and see what happens. And now we can see that we're starting to get structures like this forming. We've got a couple there. Because sometimes we do get bubbles that are a funny shape. They're not all perfect spheres. And then they can sometimes break apart and form other shapes or blend together in different ways. And that's what we want. We want something like that. But we don't want too many of these structures. Or at least I don't. You may disagree with me and you might want a few more. And if you do, all you need to do is change the value in this compare. If we change this to, say, 7, we should bias it now in the opposite direction. Let's see what happens now. Straight away we're getting these strange structures, and you can see that we're getting more of them. So yeah, that's starting to work. But I'm going to put that back to 3 and leave it like that because I think that works great. Fantastic. So we've got our volume mesher set up with our TPGeometry, and our second geometry we'll leave separately to deal with the standard bubbles. And then we can move on from here and put the final step into our Expresso expression. And that final step, if we just play the sequence again, it will be to actually kill the particles when they come to the end of the pipe, because we don't want them going past that point. So when they reach here, we want to kill them off. And that's very, very easy to achieve. What we need to do, we'll, for a start, hit F3 to go to our right-hand view. Now we can see our grid spacing is 50 centimeters. So let's see where we are. This is 0, 50, 100, 150, 200, 250, 300. Okay. So when they're more than 300 along the z-axis, that's the point at which we need to kill them. So let's work this out. For a start, we need another p-pass node. So we'll bring one of those in, p-pass. And on this occasion, we do need the all group. And I will drag this in from here just to make sure that it's in this field. So we've got our p-pass set up. And then we can think about where we're going from here. Well, we need to kill our particles, so we will need a p-die node. So we'll bring one of those in. Let's see where we are. We want a p-die from the standard menu here. Bring that in. We'll place it over here and we can connect the p-pass. Now, we want to switch this on at certain times. So we'll give it an on port. And we've got it set up so far. The next node that we need will be a get data node, a p get data. So we'll bring one of those in. We don't want the set data that's here, we want the helper, so p get data. We'll bring this in, connect the output from the p pass, and then we can decide what we want. Well, we need a position port at the output stage, and then we can move on from here and start working out what we're going to do next. Well, we're only interested in the position along the Z axis. That being the case, we need an adapter. So we'll come into our Expresso and we'll get a hold of a vector to reals. And we can plumb the position into the input. We can then take this Z output port and use this within a compare. So we'll bring in a logic compare, connect the Z, and we can compare to greater than or equal to, and it will be 300. And finally, we can connect the output to the on port of the P die, and that completes our expression. So that's our Expresso all taken care of, and we can see if this thing will work. So let's run the sequence and see what happens. And we can see that that's working nicely. Now, I think we can allow the particles to go a little bit further, perhaps to 350. Let's open up our Expresso expression and make this happen. Let's make this 350. And let's see what happens now. Yep, that's fine. I think that works well. For me, that's doing the job. And they are looking really good, aren't they? I mean, you can believe that they are actually bubbles passing through a fluid within a pipe because of the various techniques that we've used. And I think it looks great. It really is nice. So yeah, that's how you go about it. I mean, what I did in my original, I created some textures. We'll just take a look at that. We'll take a look at the textures. We'll just go into here. Now, the glass, all I did in here, the base colour is switched completely off, so 0 for the base colour, weight. And the reflection I've worked with, and the transmission. In the reflection, the IOR I've changed to 1.7. So the index of refraction, 1.7 in the reflection, which is the index of reflection, or index of refraction, I should say, for glass. I think it's between 1.5 and 1.7 if I remember rightly, but 1.7 worked well for me, so I went with it. And then I just turned the weight up on the transmission to 1, and that's all I did. The rest I left alone. And that gave me quite a convincing glass texture. The water, similar. Again, the colour, turn the weight down to 0. The reflection, index of refraction 1.333, which is for water. And then I changed these colours. I just made them just a very light cyan for the reflection and a slightly deeper cyan for the transmission. And that's all I did there. And then finally the bubbles, I literally created a texture that is invisible technically, but what I did here, again, no colour, so the weight down in there for the base. The colour here I've left white, and here as well, because they're air is technically invisible, so there's no reason to give it a colour. And the index of refraction here, 1.0003, which is the index of refraction for air. So they literally are air bubbles. But that I just did that because I thought that it was a good idea to do it, and it did give me a very pleasing result actually. The other textures I've got here, they're just for the various other elements that I've added here. I mean, this is just a simple cube, and then these flanges and tubes I've just added to just make a sort of little scene for it really, and I put a plane in for a floor. But you don't have to do any of that. I mean, you can if you wish to, but they're very, very basic textures. I mean, this is just a metallized. I've just given this a 1 here in the metalness and left the basic colour the same. Haven't really changed anything much. Bit of roughness in the reflection, left the IOR at 1.5, which is basically good for metal, and then a little bit of anisotropy. I can never say that word, anisotropy, I think it is. A little bit of that in there, and then that's it, because you don't need any transmission or anything else really. So that's all I've done there. And then a very basic floor texture, again just a little bit of roughness here, and that's all I've done. I mean, I've just really kept it simple, and the same with the box here, just giving them different colors and a little bit of roughness. Change the IOR just slightly, because I didn't want a really reflective texture. And the same with the spigot here, I've just done the same thing. I mean, this color could be changed to a green, but yeah, I just kept it very simple. But anyway, that is how I went about it, and I have made a little video of this, and I'm going to show that to you right now so that you can see what it looks like. And it's not a finished product as per usual. It was just something I put together quite quickly for this tutorial. But anyway, I'll show you it now and you can take a look. Overall then, not too bad a result. And that is how you go about building a rig to move bubbles through a fluid within a pipe. Well, at least we're pretending they're in a fluid within a pipe. And it does work quite nicely, as you've seen. And that just about brings us to the end of this tutorial, because I've shown you what I wanted to, and as always, I'm really hoping that you've found this one inspiring and that it's given you a few ideas for things you may be able to incorporate within your own projects. And if you have enjoyed the video, please give it a like, and if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings us to the end of this one, so I'll see you very soon on the next tutorial.